Okay, let's finish this Unit 11 review. I am now on page 27. The first two problems want me to solve by completing the square. So this is where I want my leading coefficient to be a 1, and we haven't practiced any problems where they weren't a 1, so we don't have to worry about that. And then the next step is to get the constant over on the right-hand side, which is different than factoring and which is different than the quadratic formula. Factoring and quadratic formula, we want it to say equals 0. But completing the square, we want to move this constant over here. So I'm going to subtract 2. So it's going to say x squared plus 6x equals negative 2. On this one, it's good to go because it already has the constant on the right-hand side. Okay, next thing we do is we take our b over 2 and then we square that value. So which one's the b? The 6. So I take 6 over 2. And then what is 6 over 2? 3. And then I square the 3, which makes how much? 9. Okay, this number that I get right here, this is what I'm going to add to both sides of the equation. So to the left side, I'm going to add my 9 that I just got. And to my right side, I'm going to add the 9 I just got. Because what you do to one side, you have to do to the other. Well, what that does is it makes this thing what's called a perfect square trinomial. So it factors as some quantity squared. Since x is the letter, x goes here. And then I come back and I look to see what this number is right here after I reduced it. And then that's what's going to go right here, x plus 3. And if you actually work this out, x plus 3 times x plus 3 and FOILed it out, you would get this back up here. So mathematically, it's all good. Okay, on the right-hand side, I can combine like terms. Negative 2 plus 9 makes 7. Okay, at this point, if I want to make the squared go away, I square root both sides. Remember when you square root something that you have a positive and a negative answer. So I have a plus and a minus, square root of 7. I cannot take the square root of 7. I cannot break down the square root of 7, so I can't do anything here. But now to get x by itself, I have to move the positive 3. So how would I do that? I would subtract 3. And if I subtract 3, it's now going to be a negative 3 on this side, and I recopy the plus minus square root of 7. And there he is. Okay, 27. This one is already ready to begin because the constant's on the right-hand side. So I'm going to take my b over my 2, and I'm going to square that. So what's the b this time? The b is a negative 10. So I take negative 10 over 2, and I square that. So now let's reduce. Negative 10 over 2 makes negative 5. And then what do we get if we square that? 25. Well, 25 is what I'm going to add to both sides of the equation. So the left side, I recopy, and I'm going to add the 25. On the right side, I'm going to recopy, and I'm going to add the 25. Okay, on the left-hand side, I am now ready to factor this, which is a quantity squared. X is my letter again, and then I come back here and I look to see what I got when I reduced it, which was a negative 5, so minus 5 is what goes there. I can combine these to get a positive 5, and now I'm ready to get rid of my squared, so I square root both sides. Remember, we get to slap down that plus minus. So x minus 5 is all that's left on the left. Plus minus, you can't take the square root of 5. You can't break it down, so that's that. And then to get x by itself, how do we move a minus 5? We add 5. So if we add 5, it's going to be a positive 5 on this side, and then I just recopy. Plus minus square root of 5. And there he is. That's completing the square. It's not so bad. Okay. This section, we get to solve by our method of choice. So that includes factoring, the square root method, quadratic formula, completing the square. So we have several choices. Number 28, this is simple. There's no x in the problem. I'm square rooting. So I square root both sides, slap down my plus minus. What's the square root of 25? 5. Done. So we have a negative 5 for an answer, and we have a positive 5 for an answer. Sometimes you'll see your answer written as a set with the smallest number first and biggest number last. So I just wanted to show you that. Okay, when I look at 29, once again, I see no x, so I'm going to do the square root method again. Now, I could also factor it because I notice it's a difference of squares, but I'm going to do the square root method. So to get Mr. X squared by himself, I'm going to move the minus 9 by adding 9. The 4x squared would drop. 0 plus 9 is 9. And then I'm going to divide both sides by 4. I can't divide that or get anything nice, so I'm just going to leave it. X squared equals 9 over 4. And then to get rid of your squared, this is when we square root both sides. Remember, when you square root something, you have a positive and a negative answer. And this right here means square root of 9 over square root of 4. Well, square root of 9 is 3. Square root of 4 is 2. And there he is. So I have a negative 3 halves as an answer and a positive 3 halves for an answer. Okay, looking at 30. So because there's an x squared and an x, the square root method's out. So I could try to factor it. I could do the quadratic formula, or I could complete the square. So I'm going to see if I can factor first. So remember, to factor, we do want this side to say equals 0. So I'm going to move this 1 by subtracting it. So that's going to leave me 0 on the right. On the left side, I drop the x squared, I drop the plus 8x, and then I can combine the 8 and the minus 1 to give me 7. So I'm just going to see if it factors. Not everything factors, so I don't know until I get there. So I know there's no GCF. I know there's 3 terms, so I'm going to take my a times my c. A times c makes 7. I want them to add to be 8. So is there anything that multiplies to be 7 that adds to be 8? You betcha, 7 and 1. Okay, this one factors, so I'm going for it. So it's a shortcut because of the 1 in front. So it's x with a plus 7, and it's x with the plus 1. And then I do need to solve because there is an equals in the problem. So this is simple. I just set x plus 7 equal to 0 and solve that. That makes negative 7. I set x plus 1 equal to 0 and solve that, and that makes negative 1. And there they are. Okay, 31. I'm going to try to factor again. So I'm going to make this side say equals 0, so I'm going to move this little minus 8 by adding 8. So if I do that, I'm going to have a 0 on the right, drop the 2x squared, drop the 12x. I can combine the 10 and 8 to make 18. So if I try to factor this, first I look to see if I have a GCF, and I do this time. All of these can be divided by 2. So I'm going to pull out the 2. They don't all have x's, so it's just a 2. So 2 times what gives all that back? 2 times x squared makes 2x squared. 2 times 6x makes 12x. And 2 times 9 makes 18. Okay, I'm going to cover my GCF up. I'm going to try to factor what's in the parentheses. I look to see if this has a GCF. Nope. I see that it's got 3 terms, so I'm going to take my a times my c. A times c makes 9. I want them to add to be 6. Anything multiply to be 9 that adds to be 6? Yep, 3 and 3. It's the 1 in front, so it's the shortcut. So it's x with a plus 3. And it's an x with a plus 3. And then Mr. GCF, shoo, drop him. Okay, now to solve, I'm going to set all my factors equal to 0. So when I set my first factor 2 equal to 0, that doesn't make sense. 2 doesn't equal 0, so that gets ignored. What do you get when you set x plus 3 equal to 0? Negative 3. And if I set the other x plus 3 equal to 0, I get another negative 3. And we don't have to write that twice. In Algebra 2, you'll learn to say that x equals negative 3 with a multiplicity of 2 because it happens twice. And that has a significance on how the graph looks, but you get into that later, so don't worry about that now. Okay, 32. I'm going to see if I can factor, just because I love to factor. I'm going to make this side say equals 0, so I'm going to subtract the 1. So if I subtract the 1, I've got 0 on the right, drop the x squared, drop the 7x. I can't combine that with anything, so drop the minus 1. No GCF. If I try a times c makes negative 1. I want them to add to be 7. Does anything multiply to be negative 1 that adds to be 7? No. Okay, I can't factor this. So I'm just going to do the quadratic formula. Now, I could definitely complete the square if I wanted to. But I'm going to do this with the quadratic formula. So my a is a 1, my b is a 7, my c is a -1. Remember, it goes x equals the opposite of b plus or minus square root. I'm going to take a moment and calculate b squared minus 4ac just right over here. So parentheses with the squared on the outside, b is a 7, recopy minus 4, parentheses, a is a 1, parentheses, c is a -1. Let's just see what our dear discriminant happens to be. So I'm going to type that in the calculator, just like I wrote it on my paper, which was not like that. 7 squared minus 4 times 1 times -1. I get my discriminant to be 53. Since my discriminant is a number bigger than 0, I know there's going to be 2 real solutions. I just need to find them. And then all over 2a. 2 times 1 makes 2. The next thing I would try to do is break down my square root of 53. So I'm going to check to see if I can take the square root of 53 and get something pretty. I can't. Then I start looking to see if 53 can be divided by any of my perfect squares. 4 doesn't go. 9 doesn't go. 16 doesn't go. 25 doesn't go. 36 doesn't go. 49 doesn't go. Now the next number is going to be bigger than 53 itself, so there's no way that's going to happen. So 53 is prime. Nothing goes into it. There's no perfect square that goes into it. So this is my answer. X equals -7 plus or minus square root of 53 all over 2. And that does not reduce. I can't reduce those, nor I'm not allowed to, because that's a 1 in front and I can't reduce both pieces. Okay, number 33. I'm going to try to factor just because I like to do that. And then if it doesn't work, I'll probably do quadratic formula again. But you definitely could do completing the square. So remember, to factor, this does have to say equals 0. So I'm going to subtract the 6x. So it's going to say x squared minus 6x plus 10 equals 0. Let's just see if I can factor it. Does it have a GCF? No. 3 terms. Let's try our a times our c, which makes 10. I want them to add to be -6. Is there anything that multiplies to be 10 that adds to be -6? 1 and 10, 2 and 5. No. Okay, it doesn't factor. So I'm going to go ahead and do quadratic formula, but if any of you wanted to complete the square, you could. So a is a 1, b is a -6, c is a 10. All right. X equals the opposite of b. What's the opposite of -6? +6 plus or minus square root. Okay, I'm going to take a moment and figure out my discriminant. My b squared minus 4ac. So my b is a -6 minus 4. My a is a 1. My c is a 10. And I'm going to type it in the calculator just like I wrote it on my paper. So parentheses, -6, close the parentheses, square it. You got to have those parentheses or you're going to mess it up. Minus 4 times 1 in parentheses times 10 in parentheses. So I get a -4. Remember, if your discriminant is a negative number, there's going to be no real solution because you can't take the square root of a negative until you learn about the imaginary number system. So all over 2a, I can't do this. You can't take the square root of a negative until you learn about the imaginary number system. So there is no real solution. In Algebra 2, you'll have the fun experience of finding the 2 imaginary solutions. All right, that's our review. I wish you the best on your test. Thank you so much.